So if you don't know, you're at a eTextile Sew Along. A little bit about what I do. So I'm currently a student at Carleton University with the Creative Interactions Lab, and I'm researching e-textiles. So what that means is electronic textiles. And I'm looking at how we can have people with no experience in this area start crafting right away. And I'm also interested in how we can prototype accessible clothing. So with e-textiles, we can do a lot of cool things. Like, for example, you can have a shirt that comes off when you want it automatically, or comes together and puts on automatically. So there's a lot of cool things we can do in terms of accessibility. I'm going to go over some of those things today. Okay, so a bit about what you're going to see tonight. The first part, I'm going to talk about Wearable Bits, which is my research and my e-textile toolkit. But it's also a good way to introduce you to all the cool things that you can do with e-textiles, because there's a lot of unexpected stuff that you just wouldn't imagine based on the wearables we have now. In the second half, I'm going to get into some of the finicky things with how to actually make e-textile circuits and the things you need to know for sewing, because it's a little bit different than regular sewing. In the third part, because we're all trapped inside our homes right now, I'm going to talk about fun things that you might have in your kitchen or in your craft drawer that you can use to start building circuits. And then the final thing is we're going to do an e-textile sew along. We're going to make this fun little e-textile bookmark for reading in the dark. And then when you snap it together, it turns on. The cool thing about this little project, this little circuit, is we can actually also use it to test if items around our home are conductive. So it has this little snap to turn it on and off, but if you place a conductive item in the middle, you'll be able to see if it's conductive or if it's not conductive. Okay. So obviously everyone won't have the tools for today, and that's okay, that's expected. So as part of this residency with Diamond, I've been doing electrostitches.com, which is a website that goes through all these steps in much more detail, so you can do it at home without instruction. And it has everything from these slides. So if you don't catch something right now, it'll also be there. And Diamond is recording this too, so you can check out the recording afterwards. And again, we're going to be covering a lot. The biggest thing is not to worry or try to memorize all the details. It's all on the website. So just relax and enjoy, and then you can also build stuff later when you get the tools. Okay, so the first part is a bit about my research and the toolkit called Wearable Bits. What got me started on this research is that there's so many skills that go into building wearable e-textiles. So you have to know how to sew. You have to know how to create a piece of clothing. You also have to know about how to build electronics. And then on top of that, if you want to control it, you need to know how to code. So I was trying to think, okay, we want to get people creative. We want to get people building stuff right away. How can we make it easier, and how can we make it so they don't need to know all of these skills in order to get started? So what I came up with was this modular toolkit. So the idea with this, I'll show you guys a quilt of all the components. And we're going to go into each one and the kinds of things that they can do. So the idea with this is that you have these individual modules that kind of like puzzle pieces can attach together. And then as you broaden that, you can build anything. You can build a t-shirt, pants, jackets, hats. We've seen people make almost anything. Shoes are a little bit tricky, but you can still do it. And how this works is that each module is a different type of e-textile component. So you could have something like a stroke sensor and then combine it with a push button, or combine it with a stretch sensor. And I'm going to go into all these in a bit more detail. So what can you build? Last summer I did a workshop where I had pairs build their own ideal e-textile prototype, so like the wearable of their dreams. I'll talk about a few that I got really excited about. So the one in yellow right here, that's actually an e-textile flapper dress, so like the 1920s Great Gatsby dress. The idea with this one is they want to use the fringe of that kind of dress and turn it into a stroke sensor. So as you're dancing in your flapper dress, it can make music. And that's really nice because it's about the type of garment and where you would wear it. So you're going to wear a flapper dress while dancing, and then it responds to that. Another really exciting one was someone wanted to make a pregnancy wearable, but they want to kind of go beyond just data tracking and all those things because you're already really aware of what's going on inside. So instead, what they did was they put a stretch sensor around the stomach. Oh, you got a question? Oh, just as welcome. Okay. So, Jean-François, is there a question? Oh, okay, thumbs up. Okay. So the idea with this pregnancy wearable is that they want to put a stroke sensor on the stomach. So the idea was that when the baby kicked, your shirt would change color. So it'd be this kind of thing where you're expressing these things that are internal and making it for the people around you. So a lot of these had to do with why we wear clothes. We usually wear clothes for certain environments or to go in certain situations. So for example, I might wear formal wear to a wedding, but right now I'm at home, so I'm wearing some cozy clothes. So with this type of toolkit, you can really explore what you would want for different situations. Okay, so what's possible with e-textiles? I mentioned there's a lot, but we'll go into some details so you can get a better idea. So just to summarize some of the technical part and make it a bit simpler to understand, with wearable computers, you have your sensors, which are gathering information, and then you have your actuators, which are the actions that your wearable is doing. So I'll go into what each of one of those means and some examples of them. So with sensors, you can think of like the senses that you have in your on your body, right? Like I can see things, I can smell things, I can taste things, and that's how I get information about my world. Wearable computers are the same way. So they use different types of sensors to gather information and then do things with that information. One of the really cool ones is the tilt sensor. So with this, how it works is there's a weighted bead or conductive beads. And what you do is when you're swaying or moving, it starts moving around so it can measure like which directions you're going. And this is interesting because it's actually how the old pedometers worked, is that they would measure your sway and then count that as a step. But you can do a lot of things, like you can make wearables for dancing or any type of movement. You can make like controllers with your hand that will know certain actions. A potentiometer. So this is a complicated word for a very simple thing. So you can think of like the volume dial in your car. You're slowly changing it up and slowly changing it down. A potentiometer is that. So it's measuring gradual changes. So this means you could touch a little circle on your shirt and it could turn like, I don't know, a light on, or you could change a volume, or a lot of different actuators that I'll talk about later. A slider is a similar idea, so it's a gradual change. And with this, you can think about like a light dimmer. So when it's all the way up, your light's on and you can slowly turn it down until it goes off. Stretch sensor. So this is a lot like it sounds, it's measuring stretch. So for example, if I had a stretch sensor woven into my shirt, I could measure like if I'm pulling. And this is really nice because you can do really subtle interactions. Like I could pull on a cuff and it would know that. So it doesn't have to always be so obvious to the people around you what you're doing. Stroke sensor, this is the one I mentioned with the flapper dress. This one's fun because it's just so creepy. So these are made with conductive fibers, so they look like hairs. And the way is they stick out, and then when you stroke them or touch them, they come together, and then your wearable computer can sense that. So with the idea of it being on a fringe of a dress, you can see how it fits that location. Pressure sensor, so this is measuring how hard you're pushing on something or your weight on something. So for example, if you had a pressure sensor in your shoe, it could measure how you're moving around and the steps you're taking. A button is when two conductive pieces come together. So with this example, it's actually using the sweat in your skin. So all of us have sweat, which makes our skin conductive. And this is how your phone recognizes your finger touch, on your smartphone. It's able to do that because your hands are conductive. So the idea with this one is I have two conductive pieces embroidered in, and when your finger's in the middle, it connects the two. So it's measuring the conductivity. Pinch sensor, this is a similar idea. So you could have something where I'm like pinching the cuff and it knows that I'm doing that. Touch matrix, you can think of this as like, if any of you have an Android phone, a lot of them have that graphical password that you put in. So it measures where your finger is on those touch points. This is the same idea. So if your finger is anywhere within those the crosshairs, it'll know where your finger is. So you could have like some kind of secret password you put in, or you can use it as a controller. Okay, now on to actuators. So actuators, these are the actions that your computer can take. So it's gathering information with the sensors, but now what can it do? If we think about the human body again, these are the type of actions that I can take after I learn something. So for example, I can change my gaze, I can eat, I can grab something, I can move around. These are the actions that your computer can take. Okay, so one of the common ones is vibration. You can imagine like the vibration in your phone. I'm going to talk about a project a little bit later where I made this necklace that massages the back of my neck. So you can do a lot of things. So, for example, it looks like it's a regular necklace, but actually it's providing me like with a little neck massage. A light. So these are sewable lights, which means that you can sew them into your project, and then you can have it dim or like gradually change, or it can be an on and off thing. Color change. This is my absolute favorite one. So what happens with this is we can actually make garments that change color. So I'll show you an example. This is thermochromic fabric. So it changes color with heat. So it went from blue to white with my breath. These shirts used to be really cool in the 90s, but you would get these massive like sweat under your arm. It looked like you were sweating, but it was just the heat. The cool thing with eTextiles is that we can control where the color is changing. So you could have a shirt that like reveals a message, or, you know, changes depending on certain environments. So there's a lot of fun stuff that we can do here. Heat, this is great for us in Canada. You know, you can make something like gloves that warm up, or a jacket that warms up. Speakers, this one's really fun. So this is just like a regular speaker. You can make sound, you can make, I don't know, music, voices, anything you can do with a regular speaker, but this is entirely soft. So what we do is with an embroidery machine is we embroider in this shape, we add a magnet, and what it does is it then vibrates with whatever sound you're making. So you could have, if these are like woven into, for example, your curtains, you could have curtains that make musical sounds. There's so much stuff you can do. And the fun thing about eTextiles is they're actually playing off of a lot of the things that are already part of sewing culture. And a lot of the tools that we use in sewing are already conductive. And I'm going to talk about a couple of these tonight. But just for example, like safety pins, zipper pulls, and snaps. Anything that's metal is typically conductive unless it has a plastic coating. So then you can incorporate these in your circuits in fun ways. Some examples, I made a zip up slider. So I just turned on these lights as I pulled up the zipper pull. Using a metal button, I made it so you could turn, like if you put a shirt on and buttoned it up, it would know that you're doing that and then turn on. Same thing with the jean clasps. So that's some of what's available, but there's also a lot more. So for example, some other things that we can do is we can actually change the shape of a piece of clothing. So there are these special threads that will remember their shape. And then when you apply electrical current, they'll go back into another shape. So you could, for example, have a shirt where when it's hot outside, it immediately shrinks the sleeves. The possibilities are endless, but the tricky thing is figuring out what do people want to do. Part 2, this is going to be the introduction to eTextiles. And this is going to be getting to some of the finicky things about how you sew with eTextiles versus regular threads. So the materials we have for today, it's okay if you don't have them because they're all posted on the website. And I've also included links of different sellers that provide them. So you can just go to the link and then get the tools as you wish. And there's several options for stores, so you can pick the one that suits you best. Okay, so first, what is e-textile? As I mentioned, it's short for electronic textile. And what this means is we can now embed conductive threads like this one with stainless steel, or I have this other one. This one's with beautiful copper, so it's nice and shiny. We can now weave these into our clothes, and they actually, or other textiles, and they actually feel like regular threads. So that's the really exciting part about this, is that it doesn't feel like technology, it feels like regular clothing. Some fun examples of some DIY projects I've worked on for the other workshops I've been teaching. So these are some e-textile gloves that respond to different gestures. So this one, when I'm putting my fingers together, the lights turn on. So you can have things that respond to how you're moving, and all that's happening here is that these two conductive pads are coming together, and it turns it on. And the other one, this is a simple one. This one is the same idea. So when I connect my fingers together, but this one's nice for biking, because if you were biking at night, you could signal that you're going one way or the other. Now to the massaging necklace. So this is the one I was mentioning earlier that has vibration motors in it. So the way that this one works is the neck part is actually a connection. So when I put it on, I have two motors, one here and one here, that will provide a vibration. So it's like giving me an upper neck massage, which is like perfect for when you're like at the computer and hunched over. And the great thing about this is these are really tiny motors, so it doesn't make any sound. So I could be wearing this necklace and no one would know that I'm secretly getting a neck massage. Some other fun examples. So I love doing embroidery with e-textiles, and you try to use techniques that hide the fact that it's technology. So that one I showed with the color changing fabric. And then I'm also working on this other one that's going to be like a book cover. So the idea is I can use my book cover as a controller for certain things. Some other fun examples. So another technique is rug hooking, which is how you can make really furry things. So for example, if you wanted to make a rug or like a tapestry or, like a jacket that was really furry. With this one, I just added conductive threads in when I was doing the rug hooking, and then I could use it as a controller to turn on and off lights. Some other fun examples are just using them as raw materials. So I went to a spinning workshop where I incorporated conductive material and was able to make conductive yarns. And then afterwards, I was also able to then weave these into an actual textile. So this textile right here is actually measuring if you're stretching it. So you could have a piece of fabric that measures the stretch or measures certain movements that end up stretching the fabric. One thing that's really interesting about e-textiles is that you can have this like craft approach to electronics. And I'm not the first to suggest this. There's a lot of research in this area. But for me, I came from an electronics background. And when I had to buy a bunch of components, I spent about like $300 buying individual components. And the interesting thing is I didn't really know what was going on underneath. Like if I bought a tilt sensor, I didn't really know how it worked, but I just knew that when I plugged into my project, it would measure tilt. When you take this craft approach to electronics, you're actually building everything out by hand. So you ended up being able to customize it as well. So for example, if you want a tilt sensor that measures 6 directions, 8 directions, 12 directions, you can do that. And that's the coolest part, is being able to actually see what's going on underneath. And the other thing is, with the toolkit I mentioned before, Wearable Bits, I was able to make all of those components using these 5 materials. So it means you can just purchase the raw materials and then incorporate those into your projects. So the one we're going to be focusing on today is the conductive thread that I mentioned before. It's made with stainless steel. It feels furry, but still feels like a textile. One thing to note if you're using it though, is that it knots very easily. So just expect to like take a bunch and then you'll get some knots, you'll cut them off, it'll be okay. Okay, so now we're gonna get to more of the introduction to electricity. So what is a circuit? I'm gonna be talking about circuits a lot tonight. A circuit is just the path the electricity flows in. So you can imagine like a circle. With this bookmark, it's going through the LED, the light, it's going through the battery pack, it's going through the snap, and then it's going back around. So it keeps going in the circle, and that's what keeps your project on. I'm also going to be talking about traces. What a trace is just the line connecting two different components. So we're going to be sewing a lot of individual traces. And when I say a trace, it's just one line of sewn conductive thread. In terms of how electricity works, it always moves from the point of the greatest electricity to the least, or greatest power to the least power. So what this means is when you look on your battery, you'll see that there's a positive and a negative. And when you have it plugged into your circuit, it's going from the positive down to ground, negative. The switch, which we're going to be using as sewing snaps, is just a break in your circuit. And then when you put it together again, your project can turn on and off. Okay, I've been talking about LEDs. What does that mean? An LED just stands for light emitting diode, and a diode is just a way of saying that the current can only go through one way. So it means that it matters which way your LED is put. So whether you have the positive on one end and the negative on the other, that's going to matter. The other thing we're going to be using is a battery holder. As you might guess, this holds your battery. One side will connect to the positive side of your battery, and the other will connect to the negative ground side of your battery. In the example that we're using today with these little battery holders, the one with the arm is the one that's going to be the positive side, and then you're going to have your battery facing down, or the negative part of your battery facing down. Okay, a few things about battery safety. The batteries we're going to be using today are 3 volts. They can't do much, but there's some key things you need to know when using them. So one really important thing is just not to leave them around. These are really dangerous and deadly if swallowed. So you want to keep them away from any young children or pets, and just make sure that they're put away. The second thing is to always unplug projects you're not using. So you've built your eTextile, that's great. Once you've done it, take your battery out and store it in a safe way. The best way to do this is to use a non-conductive container. So for example, a plastic bag or a plastic container. And another thing that I see a lot is that people tend to store their batteries together. This causes them actually to heat up. So if you have your batteries touching, it'll actually close the circuit, and that means that they'll be feeding off of each other, and eventually you could cause some damage. So just make sure you store each battery in its own bag and just keep it separate and away from children and pets. Okay, safety stuff out of the way. This is also on the website, so if you're doing this at home, this will be there. Okay, eTextile sewing tips. The first one is don't lick the threads. So usually when we're sewing, I do this a lot with regular threads, is when I'm trying to get in the needle, I'll lick it to make it thin, and then I'll put it through. Because these are made with stainless steel, copper, gold, you don't want to be ingesting that. So try to use a little threader tool, or I just snip the ends of it to help it go through. The second one, I'm going to talk about this a lot. The orientation of your components matter, and I'll show you some ways to test for that. So you want your positives going to positives and your negatives going to negatives. The third tip is to wrap your threads around individual components several times. So if they're loose and hanging off, it means that they're not going to be as conductive and as strong, so the current might not go through. So for example, with these components, they all have holes in them for sewing, and you're going to want to wrap it around tightly a couple times. Another interesting thing when you're sewing is you can often just grab a thread, use it, and then when you run out, just grab another and keep going. With eTextiles, this actually matters. You want to use the same thread for each individual trace. Just a reminder, a trace is the connection between two components. So when you're going from one component to another, you want to use the same piece of thread, and this will make sure that your connection's strong. If you have to cut your thread and restart at a certain point, this ends up actually causing resistance, which can make your light not turn on, depending on how knotted it is. So try to use the same one, and I always suggest grab a long thread. You can always cut it, but you can't do the opposite. Okay, a couple of tips for sewing too. A lot of people sew with just you know, an individual thread, but I would suggest actually doubling it up. So as you can see here, it's doubled and then knotted. And the reason for this is that the more conductive material you can have, the stronger your circuit will be. So it'll be easier for the current to go through. I just tend to use a running stitch, so it just means going up and down, up and down. The other thing is that you want to, usually when you're sewing, you have your loose threads, and then at the very end, you might snip them close. With eTextiles, you want to snip your threads as close to the knot as possible. And this is actually the back of the bookmark. So you can see I don't have any, I have these little nibbly things, but those are okay. You want to cut as close as possible on the back of your project. And the reason for this is that if you have a long piece hanging off, what ends up happening is it can cause a shortcut. So it can go across to another string, and you can end up your project not turning on, or you can create what's called a short circuit, which tends to heat up your project. So after you've sewn a trace, just go at the back and trim them close. As I mentioned, you can sometimes get short circuits. One clue for this is if you feel any heat. So if your project starts to warm up, that's a hint that it means that the current is not all being used. So the energy is not all being used in your project. So it ends up letting that off as heat. So that means something's wrong. Your LED isn't using the energy, so something else is. Now we're gonna get into the fun stuff. So conductive items around your home. So these are items that can be in your kitchen, your craft box. And what we're gonna actually do is I'm gonna show you how you can use the little bookmark we're gonna build later, and we can use it as a tester tool. So the idea here is that the snaps, which are the switch, act as a tester. So if you put a conductive piece of material in between those two snaps and your light turns on, it means that the item is conductive. So in this case, the binder clip. This is one that's probably in your kitchen. This is a fun one, so you can use like a spoon or a utensil to connect your circuit. So just by placing the spoon in between the two snaps, it turns the light on. This could be fun when you think about like measuring food habits. So for example, you could make like a placemat that measures like each time you lift up your spoon and each time you take a bite. As I mentioned, there's a lot of sewing supplies that are great for this. Safety pins are my absolute favorite because they keep things in place. So it means you can like make the connection strong, but also hold the clothing or the piece of fabric in a really strong way. As I mentioned before, there's so many interactive accessories that you can use as well, like buttons, jewelry. A lot of jewelry accessories too are conductive. And things like accessories like snaps and zippers. Another really good one to think about is twist ties. So twist ties are often insulated. So it means there's a metal wire in the middle, but then they have a plastic or paper coating on the outside. So what this means is you can actually use it just like you would a wire. So with this one, I'm connecting the two edges. The only thing you need to watch out for is to make sure that you snip the ends so that the metal is showing. You need a little bit of exposed material, so that way it can connect to your circuit. I wasn't able to get pipe cleaners while in quarantine, but in the lab, I always use these because they're so much fun. In the same way that you can use twist ties, you can also use pipe cleaners. So they have that insulation, the furry insulation on the outside. And again, you just need to trim away the stuff around the metal on each end, and then you can put it right in your project. So if you don't have like conductive thread with you, this is a great alternative. Binder clips, as I mentioned before, these are really fun if you want to make paper circuits. So with conductive thread, we can use it in obviously textiles, but also you can use it on paper. You know, you can like weave through a piece of paper. The fun thing with a binder clip is that you could actually have it be the switch. So when it's down, your circuit turns on, but when it's up and out of the way, your circuit turns off. So you could have something where the binder ends up being the interaction that connects your circuit. Jewelry wire is another great one. And again, if you don't have conductive thread with you, jewelry wire is a great alternative. Just because it's usually flexible, so you can still like, and tiny enough that it can go in a needle hole. So you can still like use it and sew with it. Another one that I absolutely love is aluminum foil. So aluminum foil, obviously you can put into any shape you want. You can make your entire circuit with aluminum foil and a battery and an LED. And you can also make 3D shapes. So if you don't have conductive fabric, which tends to be a little bit pricey, aluminum foil is a fun alternative. So you can also just sew this into your clothes. As part of the workshops I usually do in person is I have people build an eTextile tester tool, and then they go home and see what they can find with it. People find lots of stuff around the kitchen. So for example, like cooking plates and bowls and rulers. Some other ones, I just want to point out I think it's called Coghlan's in the far right, far top right. Those are safety blankets, and those usually cost like around $2. The awesome thing about those is that they have this coating on top, which makes them conductive. So it means that instead of buying, $7 to and up fabric, you can just use one of these emergency blankets for $2 and start building a project that still feels like, soft like fabric or movable like fabric. Some other highlights are, not that many people know this, but there are silver spun threads and yarns, and also gold yarns. And these are readily available. So maybe instead of buying the ones from the electronic shop, you can also just check out like where are the silver spun threads and purchase them from a regular store. Because these are used a lot for decorative purposes. So for example, you might have seen the old military jackets that have like really fancy gold embroidery. So the gold might be a bit more expensive, but those types of threads can be used in eTextiles.